This is Robin. So we will be discussing the question number 22, which is from the GATE 2023 physics question paper. Now, as you can read in the question, it is related to the graphene with the concepts of the lattice vectors involved, and you have to study the area of the Brillouin zone for this lattice. So basically, this is a solid state physics question, and it would requires it will require the concepts of the crystallography, about the elements of crystallography, how to write the lattice vector, and how to go to the reciprocal space. So you can go through these lectures to understand the basic concepts of writing the lattice vectors in real space and finding the corresponding lattice vectors in the reciprocal space. Now this question is little tricky because of the reasons the way the question is written is little misleading because it can take you to the wrong direction. So I will point out what can be the possible mistakes that students can make. So you have to really think in this question, what is the right thing to do to calculate the area of the first Brillouin zone. So let's read the question first carefully and then see what is the right idea which we have to put in to get the correct value of the area of the first Brillouin zone. So as you know, graphene is a two-dimensional materials in which the carbon atoms are arranged in the honeycomb lattice with lattice constant A. So the lattice constant is like this. Now they have shown in a figure that A1 and A2 are two lattice vectors. So which one is the area of the first Brillouin zone for this lattice? Now the point of miscommunication in this question to the candidates can be the lattice vectors mentioned in the question. Now to the very first side, what the idea that student can get is these are the lattice vectors. So the idea is that student might get is you have to find the K1 and K2 in the reciprocal space corresponding to these A1 and A2, and then you find the area of the first Brillouin zone. But that is wrong thing to do, and you would find the answer corresponding to this approach is also in the options of this question. But that is the wrong answer because these vectors, the vectors A1 and A2 mentioned in the problem are not primitive lattice vectors. They don't describe a unit cell. That is the meaning of this statement. In order to find the Brillouin zone, so in order to find the Brillouin zone, we need the correct lattice vectors. Unit cell vectors. So now if you see this if you keep on repeating, you won't get a unit cell because there are atoms also placed on this. So the exact unit cell vectors are these. Let's call these purples one as A1 prime and A2 prime. These are the correct unit cell vectors. So that's the trick of the question, is to mislead you to the wrong unit cell vectors, and you would find the wrong area in the real space, and then you would find the corresponding wrong area in the reciprocal space. So the first correct thing to think in this question is what are the correct unit cell vectors in this problem which can reproduce the same lattice after the repetition, because that's how you will define the Brillouin zone in the case space. So, okay, these are the A1 and A2. Perfect. Now, if you see in this problem, what would be the so if you see, if you want to write this, if this is your xy coordinate system, if you have to write the lattice vector a1, how would you write that? So basically it would be, what is the length of that? Length of that would be, if you consider this triangle, this is a, and this is 120 degree. So you can write this as 2a sine 60 degree, which is 2a root 3 by 2, which is root 3a. Now you can write the a1 vector as the components across x, which is root 3a. So you would take this as the 30 degree. So you would take this as the 30 degree, and this would give you the root 3a cos 30 x plus root 3a sine 30 y, which is root 3a times root 3a by 2x root 3a times half, which is 3a by 2x plus root 3a by 2y. Similarly, you can write a2, which is 3a by 2x minus root 3a by 2y. Now, if you want to find the area in real space, that would be nothing but a1 cross a2. So let's do the cross product, which would be, if you look at that carefully, it would be 2 times 3 root 3 a square by 2. So this is the area in the real space for the unit cell. Now, in the case space, the first Brillouin zone area, I'm using the short form Brillouin BZ for the Brillouin zone area, is given by 2 pi power d by a in R. So now here d is 2 because it's two-dimensional. So this would become 2 pi power square by root 3a square by 2, and this would give us 8 pi square by 3 root 3 a square. So this is what you get, and this is the correct option, which is option A. Now if you would have done with the wrong approach, let's say, so this was with the prime, you should be very careful over here. This is the prime. Now in question, what was given was non-primes, which were misleading lattice vectors. So if you would have chosen those things, then your AR would have been A1 cross A2 then your A1 cross A2 would have become, so if you find these A1, what would these A1 be? This would be A sine, A1 would be A sine cos 60 x plus A sine 60 y, and root 3 plus A by 2y. So similarly, A2 would have been root 3A by 2x minus A by 2y. So in this case, your A of r would become 2 times A by 2 root 3A by 2, which is root 3A square by 2. And if you would have used this area, then you would have gotten completely wrong answer, which is option C, because then AK would become 2 pi square by, which would give you 8 pi square by root 3A square, which is option C. And that is completely wrong. This is the wrong option. So be careful while moral of the question is be careful in choosing the correct unit cell lattice vector. Thank you.